All right, ladies and gentlemen, we are going to go ahead and start section 5.1, perpendicular and angle bisector theorems. So get ready and let's take some notes. All right, the perpendicular bisector theorem. If a point lies on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. Okay, so let's take a look at that. If a point lies on the perpendicular bisector of the segment, so right now, segment CD is the perpendicular bisector of AB. And because it's the perpendicular bisector, AD and DB are congruent, right? Because that's by definition, that is the perpendicular bisector. So given CD is the perpendicular bisector of AB, then that point C, is equally distant from the endpoints of the segment. That means that this is congruent, AC is congruent to CB. That is the perpendicular bisector theorem. A point lies on the perpendicular bisector of a segment. The point lies on the perpendicular bisector of the segment. It is equally distant, equidistant from the endpoints of the segment. The converse of the perpendicular bisector is also true. If a point is equally distant from the endpoints of the segment, then it must be on the perpendicular bisector. So this is helping us prove that CD is the perpendicular bisector of AB. So because CA is equal to CB, because CA is equal to CB, then we can say that CD is perpendicular to AB, and we can say that AD is congruent to DB. Okay, lots of good stuff here. All right, so let's just take a look at a few examples here. I'm just going to do a setup, and then you can do the teardown for your algebra skills. So setting up here, if you take a look at number 1, we're finding the value of x. Things you want to look for, you want to look for the fact that it is a perpendicular bisector. And the clues that I've highlighted show you that it is a perpendicular bisector, that this segment, this altitude is a perpendicular bisector. As a result, these segments are congruent. So the setup will be a setup plus 24 is equal to 13x minus 48, and then you can solve for x. Same will be the case for number 2, but you're looking at different clues. So in number 2, it's showing you that it's a perpendicular line, but it's not showing you that it's a perpendicular bisector until you see that these measurements are congruent. So you know that this line is perpendicular, and you know that this point on the perpendicular line is making equidistant lines. Therefore, this must be a perpendicular bisector. So you can conclude that these are congruent. So for number 1, we directly just used the perpendicular bisector theorem to set this equation up, but in number 2, we used the converse. The mindset was the converse of the perpendicular bisector theorem. All right, so at this point, I'd like you to pause the video and try 3 and 5. Keep in mind here you're finding now RS and AB. So you are going to have to solve for x first and then find the segment measure. You know how to do that. Pause the video, try both of those, and then I'll give you the answers. All right, so number 3, RS is 41 and AB is 118. If you did not get these correct, backtrack and check your algebra, and if you still cannot find the mistake that you made, ask me in Remind, and I will try and help you with that, okay? But I think you can find your mistake if you had a boo-boo there. All right, one more example here. So we've got if segment JK is formed by the coordinates -7, -8, and JK is formed by J, who's got these coordinates, and K, who's at coordinates 1, 4. Determine if L lies on the perpendicular bisector of JK. So let's do a quick sketch. And we are determining if L lies on that perpendicular bisector. So in order for L to lie on that perpendicular bisector, so we don't know we don't know if this is a perpendicular bisector. Since we don't know if that's a perpendicular bisector, the only way to prove that L is on that perpendicular bisector is to determine if those segments have equal measure, right? If they're equidistant. So, good thing we remember how to find the distance between 2 points. Distance between 2 points is found by using a distance formula. So the distance formula is to find the distance or the measure between, distance between 2 points. So let's review. Let's find the distance of JL. So the distance of JL is equal to, distance is equal to the square root of x minus x squared plus y minus y squared. Okay? So we've got the segments for JL are -7, -8, and -9, positive 2. So I'm sorry, I went with this one first. X minus x squared plus y minus y squared. Okay? Pythagorean theorem, a squared plus b squared, or x squared plus y squared. And that gets us the square root of 4 plus 100, or the square root of 104. If we get that same answer when we find the measure of KL, or the distance between point K and point L, we're going to know our answer. So -9 minus 1 squared for x minus x squared, and 2 minus 4 for y squared for y minus y squared. That gets us the square root of 100 plus 4, which is the square root of 104. Therefore, yes, L lies on the perpendicular bisector of JK. All right, so let's now talk about angle bisector theorems. So we just talked about perpendicular bisector theorems and the converse, or perpendicular bisector theorem, and the converse of that. Let's talk about an angle bisector theorem. All right, here we go. If a point is on a bisector of an angle, then the point is equally distant from the sides of the angle. So let's look at the givens here. Given, we know that AD bisects angle BAC, and we know that AB is perpendicular to BD and DC is perpendicular to AC. If that is true, obviously it is because it's given, then we can conclude that BD is congruent to DC. The converse of that is also true. If the point is on the interior of an angle and equally distant from the sides of the angle, then the point is on the angle bisector. So we are given that BD is congruent to DC, and we're given that BD is perpendicular to AB, and DC is perpendicular to AC. That's the given. If that is true, then we can conclude that ray AD bisects angle BAC. We can also conclude further that angle BAD is congruent to angle DAC. Since this ray is an angle bisector, then these angles must be congruent. So first we can conclude that AD is the angle bisector, which then further leads us to say that the angles are congruent. So very straightforward and basic example here. Look at what you're given. All right, you clearly have an angle bisector going on, and you know that these sides are perpendicular to the sides of the angle. So straight up angle bisector theorem, these must be equal or congruent. So you can say 4x plus 30 is equal to 9x minus 5, and solve for x. All right, here we've got the converse. So we are given that these sides are congruent and they're perpendicular to the sides of the angle. So the converse states that then this must be an angle bisector. So these must be equal since the green line is an angle bisector. So we can set 5x minus 11 equal to 8x minus 41. So go ahead and try 10, 11, and 12. Pause the video, try them on your own, and then we can check some answers. pause now. All right, so we've got answers on the screen here. I'm going to walk you through real quick your setup. You do know that this is an angle bisector. BD is an angle bisector, so you can set 13x minus 4 equal to 8x plus 11. To get that x is 3, which is going to push you into AD being 35. For number 11, you know that these segments are congruent and they're perpendicular to the sides of the angle, so this must be an angle bisector. So you can set these expressions equal to each other to solve for x. And once you solve for x, you know that the measure of angle XWZ can then be 24 by substitution. And for number 12, you've got these segments are congruent, okay, which means that IG must be a angle or GI must be an angle bisector for angle FGH. Okay. Therefore, since that is an angle bisector, 2x plus 20 has to be equal to 5x minus 37. And to find the measure of angle FGI, we can plug in our x of 19 to get 116. If you have any questions about these problems after my explanations, please don't hesitate to message me on Remind. So let's talk really quick about your homework. So you will find the assignment in Canvas, kind of directing you to go to ClassKick with the code for the ClassKick assignment. But go ahead and, if you haven't done it, we all did it in class, but the ClassKick code for this assignment is 44G and 3S. You will be using the ClassKick app on an iPad, which will allow you to write, and you will basically treat your ClassKick like a piece of paper. So you'll write, number 1, and then you'll look here at the problem, and then you'll do the problem in your ClassKick, and then write, ST equals blah, RU equals blah, and so on and so forth, okay? And then when we meet again, we'll I'll give answers, you'll check your answers, and so on and so forth. So thanks for watching, and this is a really just basic lesson. You just got to memorize those theorems and what they look like and how they help you see what's congruent. Have a great day, everyone.